All right. So this topic is actually very interesting to me because I think in a very long time, chatbots are interesting again. And I've been in the space since 2016 when we used to have like Facebook bots with buttons. And back then, everyone got really excited because they thought that they could talk to bots the way we could talk to bots today. So one of the things that's really been happening like over the last year is that the way we're designing chatbots is completely changing. We went from like a rule-based flow that you're following from step to step and thinking about all the different things that people could say and do with your new chatbot to using knowledge. And so we have to think about knowledge and information in a new and interesting way. So today I'm going to share with you how I'm thinking about knowledge bases and how you could implement knowledge bases within your LLM projects, train your LLMs so they can answer questions better. So without further ado, let's get started. And then in today's presentation, it's going to be interactive. So for example, you can scan this QR code right here on the bottom right, and you can get a copy of this presentation. Also, this presentation is on our website on Chatbot Conference. And everything that we're going to be talking about today is available here, and you can go a little bit deeper. And that includes some of the tests that we're going to be going through. So what we did for this presentation is we created a couple of knowledge bases that are following some of the structures that I'm going to be talking about today. And we created two different bots, a good bot and a bad bot. And that way you guys could play around with the differences and notice the differences between, using tags, using URL structures, folders, and so on. So that is available at thechatbotconference.com under knowledge bases. So let's get into it. So there's three main parts. So the first part is, in order to really understand how to use LLMs, we should have a little insight into how they actually work. And so how do they actually work? If you know, Chatbot GPT-3 has about 175 billion parameters. Now, some people say it's closer to 70 billion. Some people say it's higher. The point is, though, it has billions and billions of parameters. And now, when you open up ChatGPT, what you do is you type something in, and then within a few minutes, it pops back an answer, right? Now, do you think that it literally goes through 175 billion parameters in those 60 seconds or 30 seconds? It doesn't, right? The other thing that you can do is you can download one of these models, and you can get them for between 5 and 100 gigabytes. So you could actually take this really large language model and you condense it down to a very small amount of space that could literally run on your computer or on your phone. So let's think about what it is that they actually do. What they do is they've taken the internet or our information and they've condensed it down into principles. And then these principles are literally turned into math. And through these mathematic principles, it predicts the next character within a context. So the easiest way to think about a large language model is that it's a series of icons, kind of like the icon of this woman. Now, here's a couple of things that you can do to try to break ChatGPT. One of them is you could ask a question that is outside of its bounds of icons. So if you ask it a question like, to reverse lollipop, it'll get it wrong. And it gets, but Bard gets it right, okay? Another test you could do is you can give it a prompt where you ask it to start a sentence or a poem in this case and end it with the same word. So we asked ChatGPT to write a poem about chatbots that starts with the chatbot, ends with the chatbot, and it failed. And Bard failed at that experiment too. So does anybody know why Bard passed the first exam with reversing lollipop correctly? Okay, so the reason why Bard passes that is because Bard is bidirectional. It reads things left and right. Okay, so it's able to make predictions both ways. Now, ChatGPT only goes from left to right. So what do you see? Anyone could take a guess here. A woman. How old is the woman? Okay. So everyone sees a young woman? Okay, so some people see a young woman, some people see an old woman. So this is the challenge with icons, that icons are fundamentally low resolution. And so in some sense, icons give us enough information to make sense of what we're seeing. However, they could be interpreted in many different ways. And poorly defined information can't answer basic questions. For example, if I were to ask you what's her eye color, or what color is her hair, it's like you have no way of giving me that information. So as a designer, you have two main challenges as a conversational designer. And one of them is that what you want to do is you want to create knowledge bases and information that maps on accurately to the large language model so it could identify what sort of icon you're referring to. And then the second thing you want to do is you want to feed it additional information so it could answer basic questions like, is it a young woman or is it an old woman? And so in this image, you can see like on the left, she's like a younger woman, on the right, it's an older woman. So now let's get into how to do that, right? Because now we know what the problem is. The problem is that we have to give ChatGPT, for example, information, and we have to map the information to its internal taxonomy. And there's a couple of ways we can do that. One of them is through topical maps, and then using the right structures. So let's think about what these information structures are. For example, like when you take any topic, it sits within a hierarchy and it's related to other topics. So for example, you're a man or a woman, you're also a human being, you're also an American, and so on. So there's many different categories that you belong to. Now, when you're creating a knowledge base, if you're referencing multiple categories within your knowledge base, it makes it much easier for your knowledge base to know what you're talking about. So here's an example of like a good, well-designed knowledge base or a hierarchy, if you will. So in this example, we have a shoe store, and they've decided that they're going to separate it based on adults and children. They have men's shoes, women's shoes, and boys and girls' shoes, right? And so if you were to ask the model about heels, it would know exactly that you're talking about like women's footwear. If you were asking about trainers, it could be about any one of these four different options. So then the model would have to respond on who is this for. Now, if you didn't organize your information in this way, the model would have no idea that, well, trainers might be for men, women, boys, or girls. So what are some of the qualities of a good topical map? So a good topical map is going to fill out all the important entities within a certain taxonomy. So, for example, we have on the left, you have a hierarchical taxonomy of vehicles. For example, like you have personal, shared, and cargo, right? And then you have buses, trains, planes, ferries, and then for personal, you have car, bicycle, and so on. And then for cargo, you have plane, train, and so on. And so you could see like how differently this information is organized in, like if you want the Tesla site, okay? And then just by the URL structure, the robot could figure out a lot of things about what your site is about or what your knowledge is about. So there's a few different ways to structure this. So one of them is by using folders, right? So whenever you're using folders and you use it in your life already, like all the time, you're putting folders inside of folders inside of folders, right? That's because certain information belongs within other higher order category of information. And we do the same thing online when we have URLs. So for example, like if you look at these three examples with the Chatbot conference, the first one is chatbotconference.com conferences 2019 NYC. The second one is Chatbot conferences / New York City. The third one is NYC 2019, right? Just if that's all the information you had, you could assume different things about this conference. So for the middle one, for example, you might think that the conference only happened once in New York City. When you see it in plural, conferences 2019 New York City, you could assume that it happens multiple times over multiple years in multiple locations. And in the last one, if you're just seeing NYC 2019, then you might think that this is predominantly like a New York City event. So we created a test. So this is a test on our conferences, and we took some very simple data, and this data is basically like all of our conferences that we've had in the past. And there, in the first example, the bot was trained on these 16 links. And in the second example, it was trained on 2 links. Now, when you look at the links, you'll notice that the last and the first link are the same. So it's really just 15 links that are the difference. And so we could play around with it. Also, you could scan this QR code and play around with it yourself. So let's talk to the bot and see how it responds to questions differently. So this is the hierarchy. So it's good bot and bad bot. And let's say we ask it a simple question like, how many conferences were there in 2019? Now, these things don't always perform like you would want them to. Okay, so you can ask me any question about the conference. So let's see. So when I ask it how many questions were in 2019, now it's thinking. And it accurately tells me about both conferences that happened in 2019. Now I come down to bad bot, and bad bot actually has some misspellings in it too, just so you know. And let's ask it the same question and see, maybe it'll get it right. I don't know. Okay, so you could see that the data that it comes back is not nearly as readily understandable. And it also gets it wrong. It says there was only one conference in 2019. The other thing that's really important is semantics. So if we ask it a question like, how many events were there versus how many conferences were there versus how many chatbot conferences were there, I'm wondering if there's going to be a difference in the responses. Because again, that's how you tie up your concepts and ideas. What you need to do is in your data is define and connect these 3 concepts, that a chatbot conference is also a conference and it's an event, and that all conferences are chatbot conferences. So we'll ask BadBot a question, how many events were there? And so it just gives me the years, right? And it's kind of wrong, it's incorrect. Now we're asking GoodBot the same question, and it just gives me the total number of conferences that we had. Now, this data also has relationships within it. So for example, like, well, we had some speakers that spoke at multiple conferences, right? And so in order for the bot to answer questions like, how many times did Stefan speak at the event? It would need to reference multiple, fields of data and in order to be able to answer that question. So let's see. First we'll ask it, so it kind of gives me not a great answer. And this one only says 10 speakers, so which is clearly incorrect. So it kind of gives you an idea of like what a huge difference it is between both bots. And it's the same information that's been structured. So I'll show you what some of that information looks like so you can get an idea. So this is one of the things that we gave the bot. This is like every session that we've ever had, and then which event it was part of. Okay. And then the other bot got information like this. Like I'll show you the 2019. So there it is. Same sort of speakers, but it's in its own folder. And then when you go to the year, like when we asked how many conferences happened in 2019, it didn't have to think very hard. They're like right there. So this is an example of how like structuring your knowledge base into folders and having the right hierarchies and the right relationships really makes a huge difference in how well your bot performs. Now, if you look at this data, like, does anyone think that this is great data? Could you raise your hand? Is this great data? Okay, you think this is great data. This is not great data. Okay, so, but I appreciate it's good for humans. If you're a human, you could understand it pretty easily. So now let's think about like going a step deeper, and it's like, well, what should your documents look like, right? Because if your documents are poorly designed, then it might reference the right URL or the right document within a folder, but maybe the document sucks. So let's talk about that. So your goal with the document is, to give the bot the right context and semantics. And so, and these are examples of semantics, like word knowledge graphs, ontologies, and taxonomies. And those are like probably the most important pieces are the ontologies and taxonomies, because what you're doing is you're defining what your entities are within your documents. You're telling the bot what it is that you're talking about in the first place. And that way it could really grab onto that. And then most importantly is you drawing relationships between different things. And when you're drawing those relationships, then it knows that it's connected. Like New York City and Chatbot Conference is connected, or conference and events and Chatbot Conference is connected. So what's a good way to structure this data? So one is that you want to definitely use your tags. Like how many people are here familiar with like H1 tags, H2 tags, H3 tags? Okay, so like 4 or 5 people. When you guys write an article, the rest of you, what do? Do you guys not use H1, 2, 3 tags? So this is one of the reasons why you should use them. What you're doing with your article, and this is a really great article structure, okay, is your article needs to encompass everything that's important about the topic that you're talking about. And it needs to do it in a particular order. First, like when you first start the article, you have a really good H1 tag that describes what it is that you're talking about, and it has all the important entities within the title itself. Then the next thing is you do is you have that first intro paragraph is really your summary. It's not really an intro paragraph. And that summary is telling the bot what the article is about. And what you're doing is you're giving it 2 different types of summaries. You're giving it an extractive summary where you're using like literal, sentences that you're using later on in your document. And then you're also giving it a different type of summary, which is like a paraphrase summary. Okay. And then what you're doing is that you're using multiple terms and multiple words to talk about the same thing. So now it's getting the same sort of information from different perspectives. So that's the first thing you do. And then the second thing you do is all of your like main topics are going to be in H2 tags. And those H2 tags, they set up the macro context of the article. And then the micro context is going to be like your paragraphs and so on. And then last but not least, you need to provide supplementary content. So what is supplementary content? That is content that is not about the thing that you're talking about, but is related to it. So for example, if you're talking about how to build a good bot, your supplementary content would be about how not to build a bad bot or what a bad bot looks like. It would include antonyms, because the last thing you want to do is you want to create a database or a document that's biased. And if you just include good examples and all the synonyms, but none of the antonyms, well, that's what you're doing. So that's important. And then within the supplementary content, you want to use like subtopics, related topics, antonyms, questions, etc. So here's a few more tips. You guys could read those on your own time. You have the presentation. And so here's the second part of the test. And so what we did was we took the same exact article, okay? And I'll show this article to you. And the content of the article is identical. Now, the differences of the article between the first article and the second article is in the first article, we're using a great structure. We have all the proper H1s, H2s, H3s. We have an abstractive and an extractive summary. We have a table of contents. We have entities that are defined. So for example, if I bring up a topic of what it means to drink water, I'm going to define what drinking water means. Well, if I'm talking about what it means to be hydrated, then I'll define what hydration means. And now the bot knows what you're talking about. And then it has supplementary content and also has it in the form of questions. And then the second document doesn't have those things. We turned the whole thing into just paragraph format. We ditched the summary It's not abstractive or extractive. It's just a regular intro summary like most articles are. We did not include definitions or the table of contents. And so let me show you what both of those documents look like. So let's see. So this is, and so we've picked a topic that all of us do every day, and that's drinking water. So what are the 20 benefits of drinking water? And now when you look at this sentence, okay, what you know right off the bat is a few things. One is that the main topic is health benefits, okay, of drinking water. That's your main context of this article, okay? And then also the bot will know that this is going to talk about physical, psychological, and nutritional benefits, okay? Then it has a table of contents. Here are the H1 tags, right? We'll go on. Now I'll show you the supplementary content. How much water should you drink? What are the benefits? Should you drink it in the morning? Should you drink it in the night? Should you drink every day? What should you avoid? Dehydration, right? Because the antonym of drinking water is dehydration, right? It's the opposite. Drinking water is not drinking water. So that's an example of the good article. And this is an example of the bad article. Here's the title. Here are the headings. So it's the same exact information, right? Now, when you look at some of these articles, some of these topics, like improves physical performance, and then the first sentence is physical performance from a medical point of view objectively measures. So this is the definition of physical performance. It ties it to what it's about. And then not only that, but it also gives you a lot of information where it's talking about studies and numbers. And when you're talking about LLMs and you're talking about taxonomies, this is the difference between a taxonomy and typology. A taxonomy is about things that are actually factual. So when you include information that is fact-based, has scientific studies and numbers behind it, it's really going to grab onto the LLM. It's going to mirror it very well. If it's opinion-based, where we don't know if it's ontologically, like, is it true or not, it's a lot harder for the model to grasp onto it. So let's look at that second test, and we'll see how well they perform. This is the document structure test. So here okay, so the first one is what are the benefits of drinking water, which is literally the title. Let me zoom into here so I can see it more clearly. Okay, what are the benefits of drinking water? We'll ask both bots this question. So we'll do the document test. Wrong. You try again. So it gives you, a bunch of benefits. So some of the key benefits: weight loss, decreased depression. You can see how good these answers are. I mean, this is like really a high quality answer. So let's compare both of them. So it just gave us one of them, okay? Same exact article. Now it's giving you less. Okay, now let's see if it knows the list, if it could list out. Can you list out the benefits? So it gives us the first 10. Let's see how many this will give us. And so these 10 that it's giving us are going to be directly from the H2s, right? Where this one, they're kind of like a little bit improved skin density. I don't know what that means. Okay. So when you don't give the bot the right information in the right structure, and you don't train it properly, it'll start to hallucinate because it'll start to fill out those blanks of the icon itself. If we asked about like, what if it was how old that woman is, it would have made it up. If we asked it like, what's her eye color, it might have made it up. And in this case, it's making up the skin density part. So that's all I have for you today. So I'll open it up for questions. But before I do, I want to let you guys know that this is what we do. We host the Chatbot conference. We have a conference coming up on November 1st. And this is one of the topics we're going to go very deeply into, not just talking about what it is, but actually how to implement it. And this was kind of a preview of how to do that. So if you guys are interested in joining us, it's going to be online on November 1st. And then next year, we're going to have it in San Francisco so we could all see each other in person and meet each other. So, and right now it's a great time to register and get a ticket. It's VoiceFlow. So we use VoiceFlow for this. And then within VoiceFlow, they have like a little knowledge base tab. And within that knowledge base tab, you could only put in documents. And so that's why we had to use URLs for this, because there was no way to really create a folder or a hierarchical structure without using URLs. But the thing is that like ChatGPT has been trained on the internet. They've been trained on URLs. And they've been trained on the best examples. And so using URLs is like, very good. So use one H1 tag. Your H1 tag is your title tag. It tells it what it's about. Think about that as like for example, in this article, your H1 tag is the title of it, the 20 benefits of drinking water, right? And then you have your entities, physical, psychological, nutritional. That's your H1 tag. And then these things over here are your H2 tags. Those are like the main headings, the main topics within it. So your main topic and then your subtopics and your subtopics. So sometimes people use these tags aesthetically for accessibility, but the thing is that you can define what it looks like and what size it is. And oftentimes people make the mistake of using paragraph format or the wrong tagging and then just making it really nice, big, and pretty. But the thing is, when like a search engine or a large language model reads that in computer text, it's just reading it as a paragraph like everything else. So in terms of accessibility, you can make it look any way you want. You have domain over how you make it look.